So hi everybody, and thanks for being here. And it's a pleasure to be speaking at this conference. My name is Andrea Paulillo. I am the co-founder and partner of a small consultancy company here in Naples. I'm originally from Naples. I'm home. And I am an assistant professor in chemical engineering at UCL, University College London, in the United Kingdom. And the title of my talk is Complementary Forces, the interplay between sustainability, life cycle assessment, and blockchain. The first two. All right, I went very much forward. All right, so before starting, a little bit about me, and a little bit about the loop, and then I'll tell you what the structure of my talk is. So I am a chemical engineer. I study in Naples. I'm originally from Naples. I studied here at the University of Naples. I did my PhD in chemical engineering at UCL. I stayed there. I did a postdoc, and then I became a professor. And I also hold the prestigious research fellowship from the UK Royal Academy of Engineering. And I specialize in sustainability assessment and life cycle assessment. That's my specialization on what I do research and consultancy on. I have written a number of research papers, I hold research grants, and I do consultancy for a number of industrial partners. Now, an important disclaimer here. As you can see from my curriculum, I am no expert in blockchain. I know what blockchain is, but I'm not an expert. I believe you are much more than me. I'm an expert in sustainability and life cycle assessment. What I will talk about is how these concepts and tools could be implemented with blockchain and what are the advantages and disadvantages, challenges, and potential benefits. Now, a little bit about eLoop, if it works. Okay, so eLoop is, as I said, a small consultancy company founded in 2018, headquartered in Naples. We also have a small office in London, UK, which is where I live, and it was founded by a number of people who had the aspiration to contributing to the ecological transition by trying to reduce environmental impacts of products, companies, and in general human activities. So we do a number of things, but essentially we do sustainability assessment of products or technologies, for example, which there is a lot of demand, especially in Northern Europe, but in Italy the demand is growing. We do similar circularity assessment. We support companies in communicating their environmental or social performance, and in general in redacting the so-called non-financial reports, which are more and more widely used in Europe. Now, so what this talk will be about, it will be structured in 3 parts. The first is all about setting the stage. So I will define what sustainability is and what life cycle assessment is. And then I will talk about the connections, the potential connection between sustainability and life cycle assessment and the blockchain, looking at how life cycle assessment can enhance the environmental sustainability of blockchain, and vice versa, how blockchain can improve the implementation of LCA, right? So no, lo so, però ci vieni vicino. All right, so I want to do something, but I don't have my laptop link there. So I wanted to start by asking you what sustainability means to you. And this is an exercise I typically do with students in my lecture. And the reason being that most people don't know what sustainability is or how it is framed in the, typically in the research field. It is typically widely misunderstood, right? So we won't be doing this exercise. Don't do it simply because I don't have my laptop so I can't check the results. It would have been great though. But what I typically get from my students and the people to whom I present is that sustainability is all about the environment, environmental impact, circular economy, it could be conservation, ecology, and this kind of stuff. These are the typical questions I get, and I believe this would have been the answers I would have gotten from you. However, the concept of sustainability is much wider. The most widely accepted definition of sustainability was developed in 1987 in the so-called Our Common Future. It's a report redacted by the World Commission on Environment and Development. So they define sustainability as the ability of humanity to ensure that it meets the needs of the present without limiting future generations to do the same, right? It's a very vague and wide concept. There are two things which are important. One is the concept of needs, and they clearly say the needs of the poorest to which overriding priority should be given. And secondly is the concept of limitations of our technology on the ability of the environment to meet our needs. Essentially, we cannot meet our needs by what is provided by the environment. Now, another important thing that this definition captures is that, and which became evident in those years, is that economic growth is typically accompanied by environmental degradation, environmental impacts. However, we do need this economic growth, for example, to alleviate poverty, right? So there is a clear tension between these aspects. And that's why sustainability is typically depicted with three overlapping circles, which are coming up, hopefully. Here, there you go. So that's how it is typically depicted. So sustainability is what manages to balance economic considerations with environmental impacts and societal impacts. And when we balance these three dimensions, lobes, decision spaces, we get what we call sustainable technologies, decisions. So sustainability is not only about the environment. Sustainability is also about economics and also about societal impact. We typically base our decision only on the economy, the so-called bottom line, whereas we should move into a sustainable development where we balance these three aspects. So that's the key about sustainability and what I wanted to introduce to start. Now, to assess sustainability, what we need to do, we need to assess these three aspects. So we need to assess the environmental performance of a product or a technology. We need to assess its societal impact and its economics, right? And when we do these three things, we are effectively assessing the sustainability of a technology. And there are three tools to do that. One is called life cycle assessment, which I mentioned earlier, is what I typically do in research and in consultancy, which quantifies the environmental performance of a product or technology. There is social life cycle assessment, looking at societal impact, and then there is life cycle costing, looking at the economic parts, right? Okay, so as you may notice, all these three technologies have something in common, which is they have the same two words at the beginning, life cycle, right? So what underpins these technologies is that they have a life cycle thinking perspective. So they look at the entire life cycle of a technology or a product. And in fact, there is an important initiative by the United Nations Environmental Program trying to make this concept much more widely used. All right, so that's all about sustainability. Now, what is life cycle assessment? It is a standardized, widely adopted methodology. I will tell you what applications it has. That enables quantifying the environmental performance of a product. If you think about the carbon footprint that we all hear about nowadays, that's an application of life cycle assessment. And that's basically the structure of the framework. I won't go into the details, but essentially you start by defining the goal and the scope, you collect the data, you quantify the impact, you interpret the results. We'll need this framework in a second where we'll look at how blockchain can improve this methodology. Now, so there are four main features of LCA which are key. Firstly, it adopts a life cycle perspective and it looks at a wide range of environmental issues. So it is climate change, but not only. It could be resources depletion, it could be toxicity, it could be human and environmental toxicity, it could be ozone depletion, and so on and so forth. So these two things enable to identify trade-offs amongst different options. There is, most of the time, there is not one technology which is better than another across all environmental impacts. There are always trade-offs to be considered. That's why LCA is key. It is quantitative. It puts a number of environmental performance, so we can tell how much one is better than the other, and it is based on science, so we're not making it up. There is a lot of science backing this tool. Now, how it is used? Is it used? It's only research. It's used a lot, and the time I did my PhD, which was 10 years ago, the application and use of LCA has increased exponentially, really exponentially. So it is used a lot by governments. For example, the European Commission uses it a lot. There is a huge team doing LCA on their policy to formulate new policies, how to implement the policies, and how to assess whether these policies are working from an environmental perspective. I've listed here a number of EU directives, regulation that are based on LCA, the Eco-Design Directive, something which is talked about a lot recently, the Carbon Border Adjustment, CBAM. There is the Circular Economic Action Plan, the Farm to Fork Strategy. All of these require an LCA to be conducted. It is used a lot by industries, for example, to quantify the carbon footprint of their product, which can be done for efficiency purposes, or most importantly, for marketing purposes, for increasing the reputation of their brand. Unilever, a huge company, headquartered in the UK, they have a 50-people team doing that. And then, theoretically, it's also used by citizens, by us, to support decisions. So if we have two products, for example, say that have the same price, knowing that one product has a lower environmental impact might steer our decision towards that product. And for example, I show here a number of examples of products doing exactly that. So in the UK, Oatly, which is oat milk, it's it's one of the biggest alternative milk brands, and they report their carbon footprint there. Corn, again, they are, I believe, a vegan meat alternative. They have their carbon footprint here. Milk in general, they report the carbon footprint. So there are a lot of products. If you buy a ticket for a train in Italy, I believe, they'll tell you what their carbon footprint is and how much lower it is, for example, compared to an airplane. If you have ever seen this, the EU Eco-Label, which is a label promoted, developed by the European Commission on the products that are, say, top 10% products in a given category, that, from an environmental perspective, that's again based on LCA. So these labels effectively are a decision support tool, right? They should enable us to make more informed decisions, and again, these are based on LCA. So just to give you an example, there are so many applications of it, and it's expanding. And specifically for this, you can understand where the possibility of integrating blockchain are in terms of transparency, for example, to make sure that these are not simply greenwashing, but we'll get there in a second. Now, right. So as I said, I will adopt two perspectives. First, how LCA can improve the environmental sustainability of blockchain with a case study. And the second perspective is how blockchain can improve LCA. So start with the first, how LCA can assess or improve the environmental sustainability of blockchain. I will look at the case of the most famous perhaps blockchain technology, simply because, not because I like it a lot, simply because it's the only blockchain technology that's been assessed by LCA in the research, in the literature in general, which is Bitcoin and Bitcoin mining. So in this study, what they did is they wanted to quantify, as you know, Bitcoin mining, very energy intensive. Energy intensive means a lot of environmental impact. So they wanted to quantify the energy consumption and the carbon footprint of global Bitcoin mining in 2018. So one of the most interesting things they did, they linked the carbon footprint, which is the carbon emissions, right? Greenhouse gas emissions, to the hash, right? Which is, if I may use an improper word, perhaps one computation, right? So they link it to the hash and then to the hash rate. And this is interesting because there is no, doing an LCA on one Bitcoin mining doesn't have any sense because the hash rate determines the energy consumption. And that was an interesting approach they adopted. So what did they look at? They looked at two things, essentially. A, you need to do Bitcoin mining, you need equipment, you need a computer, and they looked at what computer is actually used for this. You need to manufacture the computer. At some point after typically 5 years, you need to dispose of it. And that computer will have a specific efficiency, computing efficiency, so energy consumption. So they looked at these three things, and they also looked at the geography. Where is mining happening? Why is the geography important? Because the source of energy depends on where you are. If I am in Iceland, my energy will come from hydroelectric and geothermal. If I am in India, it will come from coal. And these two are very different in terms of carbon emissions. So they had to understand where mining is happening, what share of the global mining is happening in different geographies. So what they found was that this is the carbon footprint of 1 tera ashes, okay, which amounts to 15 milligrams of CO2. Then, based on this energy consumption, milliwatt hour per tera ashes. Then what they did, they basically they looked in 2018, they looked at the hash rate in 2018, and by knowing the hash rate, they could estimate the carbon footprint and how that varies according to the hash rate. The higher the hash rate, the more energy consumption, the more carbon emissions. And they found that in 2018, Bitcoin mining had 17 megatons of CO2 equivalent of emissions, right? Now, is it a lot or not? To give you an idea, 17 megatons of CO2 equivalent is roughly the carbon emissions of a small to medium-sized European country, Croatia. So to some extent, is a lot. But of course, and again, I'm no expert, this is based on, may I say, an architecture of Bitcoin or a way of mining which is based on proof of work. As I understand, the shift to a proof of stake would significantly change the energy consumption and therefore the carbon footprint. This has not been done yet in the literature, as far as I know at least. So that's what they did. And what is also interesting, as I mentioned, they looked at the geography. Geography is key, right? So they had to understand where mining is happening. So this table shows the global share of mining in different regions worldwide. And they found that in it's mainly happening in China, specifically in these 3 regions in China, they have basically over a quarter of Bitcoin mining in 2018, and then in some proportion in Russia. And then they also reported the contribution of this region to the global carbon emissions of mining. And as you can see here, in Inner Mongolia, China, they had a 12% share of global mining, but they contributed to a quarter of carbon emissions, right? So this is telling us that the energy source in that region is pretty bad, and in fact is mainly coal. So all these 3 regions, China and Canada actually, you see where the contribution to carbon footprint is higher than the share, it means that it has a very bad grid mix, right? The opposite occurs from Iceland, Sweden, and Norway. They have roughly 4% of global mining, but they contribute to less or around 1%. Their energy source is very clean. Norway is all about hydroelectricity, like Sweden and Iceland, I mentioned, geothermal and hydroelectricity. So here it shows, so this is the value they got, right, for 1 terahash, milligrams of CO2 equivalent. They showed that if all the energy required for Bitcoin mining was coming from coal, we would double the carbon emissions. If it were coming from hydro, it would be much, much lower. And these intermediate estimates are basically estimates found in the literature from different consultancy, we may say, and what differs in this is the share of global mining that they assume to happen in China, which, as I mentioned, has a lot of coal powering the grid. So that gives us an understanding of how, actually it's the next slide, gives us an understanding of how LCA can be used to improve the environmental sustainability of the technology. It can help us identify critical stages where the impact are coming from and how we can then improve or reduce the carbon emissions. For example, in this case, we looked at essentially, I mean, I could have guessed that, but it's a lot about energy consumption. So moving to countries where the majority of the energy source is from renewable would make a substantial change. This can be applied to any blockchain technology. As I mentioned, Bitcoin, in the case of Bitcoin, is simply because it's the most famous, everybody knows it, and it's the only one that actually is in the literature. There is a lot to be done around that. Now, let's look at then how blockchain can improve LCA, which is also super interesting. And to do that, I need to first point out what are the key challenges of LCA. So, in life cycle assessment, we look at the entire life cycle of a product, right? So we need a lot of data. Think if I want to do the LCA of a car, think how many pieces are in a car and how complex is the supply chain of that car, okay? So the collection of data is very complex. LCA is time and resource intensive. 80% of our time is on collecting the data. Time intensive means it's also costly. The accuracy of data is key. If we don't have accurate data, we won't have accurate results. And there are basically issues with the accuracy, but also the precision of that data. And finally, transparency and credibility issues. Nowadays, clearly, every company is trying to report their environmental performance. They want to show they are great, they have very low environmental impact. This will improve their brand reputation, potentially increasing sales. But there is a lot of greenwashing, clearly, right? So if I read a number, do I believe that or not? Do I know how it was calculated? There is a lot of greenwashing, and I tell you, I work in this industry, there is a lot of that. So these are key challenges in LCA. So how can blockchain then improve on these challenges? Right. So to me, the most important one is about transparency and traceability, right? So if we can ensure that the data used for an LCA is held in a blockchain or is developed, recorded, distributed via a blockchain technology, we are ensuring that it is transparent, everyone can see that, and it is traceable, right? Which is really the most important element for disclosing environmental information nowadays, again, because of the issue of greenwashing. Secondly, it's about, of course, decentralization, so ensuring that that data, once there, cannot be manipulated. So I cannot make my carbon emissions lower by changing a few numbers here and there, because as you know, once it's there, it cannot be easily manipulated. If you think about what happens with Volkswagen emissions a few years ago, where they tampered with some of their data, well, you can't do that once it's in the blockchain. It can be done at the source, of course. There is a lot about efficiency, right? If we record our data automatically, potentially in real time, via a blockchain technology, the data collection is much easier. It's all up there, and it's about basically downloading and doing the rest of the analysis. So the efficiency of collecting the data is much, much improved. And as I mentioned, data collection is around 80% of our time. 80% less time means also cheaper for companies to do that. And also there are potential for integrating then LCA with other emerging technologies. I will make an example with the Internet of Things, but also a lot about big data, which is enabled, can be enabled by blockchain. There is also a lot about artificial intelligence nowadays, of course. So all these things can improve the application of LCA. And this slide, which I mentioned earlier, shows how a blockchain-based LCA framework can improve the LCA in each and every step. Starting from when we set the scope of our study, if we have all that data up there already, we are not limited or restricted in the number of think about a car, in the number of pieces of the car that I can access, because I know I will have all the data. So the data collection is easy. I'm not limited in what I'm going to assess. I'm also much more transparent on that side. As I mentioned, in collecting the data, so in the inventory analysis, it can be done automatically. It can be linked to the Internet of Things, having data, real-time data. Again, this makes stuff much more efficient. When we assess the environmental impacts, if we have data that is precise, accurate, our results would be precise and accurate, which is also very good. And then with the help of all that data, big data, it can help in the interpretation of the results and uncovering potential issues and hotspots. Now, this is one system architecture that is proposed by a group of researchers, where they showed how we can integrate LCA with blockchain and the Internet of Things using 4 basically levels. So the infrastructure is made by Internet of Things, smart sensors, the stuff that can, for example, record energy consumption in the manufacturing of a car and stuff like that. And of course, the storage of this data, which can be a bottleneck. Then this data is then recorded in a blockchain-based LCA. So we will need, the stuff we need are the inputs, energy, water, and all kinds of stuff we use in our products, and all our emissions and the waste we produce. The blockchain-based LCA would process, record the data, and make it available for performing LCAs. And the applications there are some here, but essentially are so wide. They can be used for energy saving management. They can be used for waste management, product information, environmental communication, and so on and so forth. And the users are, again, what I mentioned earlier, governments, NGOs, consumers, and enterprises. So there is a lot of potential out there. It's the actual applications are very limited. We looked into literature to see, is it actually done? We could find only 2 case studies, and I'll talk about one now, which is about the Dutch dairy sector. So basically, in Netherlands, in 2015, they wanted to reduce the carbon emissions of the dairy sector by 20%. Clearly, you understand there are a lot of farms. There are over 10,000 farms. You need to collect data from all of them to ensure that you are meeting your targets, and this is a challenge, a lot of data to be collected. So the problem was exactly large-scale data collection from over 12,000 dairy farmers. If I had to do it manually, it would take me, I don't know, a decade perhaps. So basically, their solution was to integrate a blockchain-based LCA with big data that streamlined the data collection from all these farmers. Oh my. So what they did, basically, there was actually already a system in place for recording the nutrient use, fertilizer use in these farmers, by these farmers. They added another layer to collect additional information. This was recorded via blockchain, and then there was basically a real-time, almost, exchange between a blockchain and LCA software, which would calculate data automatically. And this was very interesting because it automated the calculation for 12,000 farmers. Then it fed back this data back to the farmers. They could see how they were improving, in real time, their carbon emissions, which would motivate them even more to achieve the targets. So clearly an interesting case study. As I said, we found only 2, a lot of potential out there. Right, so again, I'm not an expert in blockchain, but what do I see as the big challenges in integrating LCA with blockchain? There are 3. To me, the most important is about scalability. Scalability is about the amount of data you need, the amount of data that is generated you need to store, and the amount of data you need to transmit, right? The second, you have a bottleneck, clearly. And for the first, you need a lot of cloud storage, for example. One figure that is stuck in my mind is the amount of data that is generated by one engine of an airplane. Every 30 minutes, one engine of an airplane generates 10 terabytes of data for 30 minutes. Think about a continental flight. Twitter generates 12 terabytes of data. Now you understand when we are linking LCA with the Internet of Things smart sensors, there will be so much data storage first, and all these data, if we want real-time connection, will be to be transmitted, and that's another important potential bottleneck, at least in my opinion. There may be issues with data privacy. Now, I know blockchain is on privacy, theoretically speaking, from what I understand, is much safer than other ways to share the data. But if you are a company, most of the time you don't want to share the data at all, right? So if you want to enable that, your data will need to be shared there and will need to be there basically for a long time. So potentially companies or people that do not understand how that works will have issues with the privacy of their data. For example, I work with the nuclear industry. I can tell you they will never put their data in a blockchain technology because they are mad. But there is a lot about that, and there is a lot about collaborations and ensuring that in a supply chain, all the stakeholders agree to do that, and they upload and they collect the data in the same way. Only in this way we can automatize this process and then achieve the kind of efficiency I mentioned earlier. Again, these are what I see as challenges. No expert in blockchain would be happy to hear your opinion on that. And this is my, I have no idea how I did with time, but this is my final slide on my take-home message. Take-home message is sustainability and LCA and blockchain are highly complementary, right? So the LCA can improve the environmental sustainability of blockchain, and there's been a lot of criticism, for example, associated with Bitcoin mining on whether it is actually environmentally sustainable, blockchain as a technology. But most importantly, blockchain can make our life easier, make the process more efficient, and make, most importantly, the data transparent and traceable. This is really key in this field to avoid greenwashing. So they are highly complementary, and there will be integration at some point. It's not a matter of if will happen, it's about when will happen and who will do that. I'd like to do that, but again, I'm an expert in only one of the 2. And that's the end of my belief, of my talk. Yeah, thank you very much for listening, and let me know if you have any questions. Are there any questions?
So, hi, I'm Lorenzo. Do you think that this implementation will work on the Ethereum blockchain, or do you think we need just another blockchain? Because you know that blockchains are not equal. So,
it's a very easy answer. I don't know. because I'm not an expert in this. I have no idea whether it can work. I don't know the details. Technically, you should tell me whether it can work or not, actually. I don't know. But why? For scale. Okay, for scaling. With that amount of data, so basically, it's the data the problem. Okay.
But I think that we need some lot of time.
Yeah, no, but that's why I say it's scalability for me. It's again, I don't know much, but I could guess. But yeah, it's not a matter of whether it can be done. I believe it's a matter of when it can be done. When we have the infrastructure to implement this kind of integration. Sorry if I could not answer, but. Are there other questions?
No. I'm interested to understand. So you talked about these projects, no, based on blockchain, and there are many, as you showed, there are many constraints, no. So, what's the reason why this should be implemented on a blockchain? So, I mean, there are a lot of issues connected to data that are big data. We are speaking about big data. So it's very difficult to implement. So why, I don't know, a government or a foundation should select blockchain instead of a normal technology and invest maybe something to assure traceability and consistency of data? This is my...
Right, so it's a very good question. So at the moment, the way it works, if I want to do an LCA, there will be some database providers. I will go into the literature on Google. I will look for research articles, gray literature. I will look for the data, and I will put my data there, and I will source the reference. That's how it works, right? It's inefficient. I tell you because I do that. It's inefficient. It takes a lot of time. Most importantly, companies nowadays, take one company, Google. If you go on Google, Google will tell you that they are carbon neutral since 2007. I don't believe them one bit. The main problem is the transparency of this information. Because at the moment, they can tell you whatever, and they do not have to show anything for it. If we can implement that, that information will be A, transparent to everybody, and second, traceable. You know exactly what data they used. So they can't lie. So we are solving the most important issue there. The final part of my answer is that you talked about government. So this stuff is not implemented by government. It is used by them, right? So government, the European Commission, and I collaborate with them, they will do what I do, right? They will go in the literature and look for the data, right? They will not implement a database themselves, right? So if we can ensure that every single industry does that, or the big ones, once the European Commission wants to quantify the carbon emissions of something, they will have a system there which they can trust. They can look at the data, they know it's immutable, it cannot be changed or manipulated, and they can use that immediately, them, researchers, citizens. So that's the main thing. For me, the main thing is traceability and transparency, ensuring they're not lying, because nowadays, most of the stuff we see, I don't believe it. And the second part is efficiency, as I mentioned. Does that answer your question? To some extent. It answers, okay. Are there other questions? That means it's all clear.